It's going to be a video covering first look of the third generation of the NEO3, the first installation and application of this design. My new loop that I'm building, this is double back. This one's actually headed to Elk City here in 5 days for the setup. Double track module, obviously. Loop with a passing siding. As you can see, the passing siding is not in service yet. Not only a shortage of track, also a shortage of cork, which I just learned Midwest Products is now no longer in that business. Supposedly Atlas is coming out with something, so we'll have to wait and see. The NEO3, this one, a couple issues to address with this new design. Number one, cost. So with the last iteration that I had, the first two versions of the NEO were PA12 printed in SLS, and a lot of printers offering that before COVID and post COVID. The number cut down, and the prices just skyrocketed, especially when shapeways shut down. The prices really went up. So what we're seeing now is with other printers being able to get the tolerances required for this so this is an in-house printer that I'm printing in PLA, and been working with multiple designs, printer changes, settings, coming down to what I think is going to be a very robust, repeatable, and useful design. So what we've got now with the new NEO3 is a two-piece concept. It carries over some of the designs of the original NEO. This one obviously didn't, but this was a early version. But you can see we kept the index arrows. Okay, so when you mark your module and you got your 1 inch, 2 inch, or even just your 1 inch, your center line for single track or double track, the index arrows here show you where that goes front and back. We're able to print cleaner now, micro-engineering versus what the PA12 was able to do. So this is ME. I think you can figure out yourself that it's wood, but if we need to add that later, we can. We'll be coming later with Atlas wood, and then Pico wood, and then Atlas concretes. But we kept the ballast lip. So this ballast lip at the edge of your module, right? So you can ballast right up to that. You get a nice square ballast profile. You don't have to round it, like you're falling off of a cliff. A nice square, and it goes right next to the next guy, and the ballast profile continues. But a couple of things that are new. The biggest one is getting rid of the brass screw as the base, the anchor, and replacing that with a PC tie. So the problem we were seeing with the brass screw is that it was acting as a giant heat sink. And even with a high quality, high temp soldering station, like a Welland, you were still getting cold welds because you were just trying to flow across a lot of metal. Obviously with the plastics here, we can't put a flame to it. So what we're doing now is replacing the brass screw. We're still using brass screws, but that's just to anchor the fixture to the module. And then the PC tie here, there is a narrow end, so if I can focus, the narrow end and a thicker end. And the narrow end goes at the front. And then there's also the shelf here, and that shelf is what we use to secure, it's a 1.4 millimeter. It is metric for you Americans. That is to secure the PC tie to the fixture. We kept the ballast pocket around where the rail joiners go, with the PC tie now forming the back plate of that pocket. So you can ballast all around your ties, get a nice clean ballast pocket. So if we'll jump ahead just a little bit, but you can see if you're doing an MSS district, okay, insulated rail joiners, and you need to go up against a classic Freemo module, we'll be using 1 inch bridge rails now. You can see this big, ginormous size 15 Atlas insulated rail joiner just slides right into the pocket. fits with no issues. If you're doing a non-MSS, your metal rail joiner will fit. And then if you're lucky enough to come up against another NEO equipped module, then you don't have to install bridge rails, because we all know how much fun those are. And the way we address the MSS districts is with an air gap. So let me pull this guy out of the way. So you can see, pull back about 20 thousandths there. You see that air gap, but then you do the same thing. We don't have to, the rails, we don't have to worry about the rate. There's not enough weight here on the scale up the motor. Push it down. We've got a nice air gap so that we're not bridging our MSS districts. So what else we got? Covered the fixture, in-house printed. These are machined. And the only country in the world that does stuff like this, China. Brass screws, yeah. So one of the other things, like I said, when we're looking at doing these on the last batch, the PA12 SLS printed, we're looking at like 22 bucks a piece. And that was going to be cost, just get them out the door. They were going to be wildly expensive. So the good thing is with the in-house printing, and I did source a large quantity of these, so the unit cost will really get down significantly. What I'm looking at doing, like for a double track module, a fixture, not only the two PC sets required, but also a spare. Right, so sending you the base fixture, your screws, your two PC tie sets, and spare PC tie, because that's also one of the things that the two-piece addresses, right? So one of the advantages of the 1-inch setbacks is it's much harder to zip a rail. It's not impossible. I've done it several times. I've done it. But it does cut back on the risk, whereas right here at the edge, you do risk, right? A shirt sleeve or an elbow or something, right? Now with the air gap, that does pull back some of the immediate threats. You know, nothing's going to snag across it like this. But you do run a risk of shirt collar or something, or a sleeve grabbing that and pulling it up. But let's say you do. Let's say worst case scenario, you snag this, you bend it back, you stand it up, and you destroy, right? Because the weakness on a PC tie is the adhesive bond between the base and the metal, right? It's just glued together. So, well, it's not a huge loss, right? Because your guide should still be in place. You got guides front and back on these things. Focus. Got guides front and back. Pull your rails off. You know, cut them if you need to. Unscrew this. Screw the next one down, and rebuild. You keep going. Right. So this is a wear component. It is designed to be line replaceable. You get us set up. Something happens. I'm hard to envision a scenario where you destroy the base. Right, I guess that is a possibility, but so far I've been pretty rough on these things, test, and I'm not sure that's a possibility. I could see these being delaminated if you snag them, so that's certain. Not only does this thing set spacing, let's see how well we can do here with put that right there at the edge. You see I'm trying to hold two different items of focus at the same time, but I see we're right at 2.0000. The other thing, what was I going to point out? It's a challenge when you don't have a script. There's something else. The height of the rail. So one of the things we saw on earlier Neos with the brass screw being the heat sink underneath, that there was a risk of deforming the base because of the amount of heat that you're having to deliver to the screw. Since we've replaced the screw with a larger surface area of PC material, right, you don't have to flow nearly as much heat, and it's for the solder, just flows nice and smooth. You got a larger surface area, you got a solid bond. But the other thing is that when you go to press down on these, you're not softening anything. So when you get finished, all your rail heads are level plane. So this thing will not rock. See, I'm not high on the outsides and low in the middle. Everything is flush. This steel straight edge is touching all four tops of the rails. So we're not trying to set up a butt joint, you know, with, you know, different comb fingers all over the place. It's nice and flush, everything's straight and level. And it's gonna mate up perfectly to another NEO module. Or if you're unfortunate to have to put in bridge rails, then frankly I'd make the other guy do it, because you don't need bridge rails, he does, but that's just me. But you know, you're set at 2 inches. Now you do have to do some of that modeling skill stuff, getting, you know, 12 inches from side to side. So you're responsible for setting the left and right. Oh, the way I set this was showed in another video. I'll cover it real quick. I'll take a nice square piece, put it right there. You don't want to put it up too high, right? Because you're going to come in and like, hey, I'm going to try to, where's my rails? My rails straight? So just high enough to there. But that's covered in a couple other videos. And then I'll probably do another installation video with these newer ones, just because the technique's a little bit different. Once everything's finalized and any of the changes are worked out. So this is what we're at. Like I said, we'll be the Elk City setup next week. We're running a lot of traffic over this thing. Find out if there's any deficiencies or weaknesses. Need to come back and rework the design. But these should be ready to start going out the door, hopefully by the end of June.